Hey there, everybody. Today's video is all about factoring. You ask, what is a factor? Well, factors are what you can multiply together to get another expression. For example, 2 times 3 equals 6. So 2 and 3 are factors of 6. So when we ask you to multiply something like 2x minus 3 times x plus 1, you've seen this before, and you can multiply these two binomials. Binomial because there are two terms. So let's go ahead and multiply that. 2 times x, 2x times x is 2x squared. Then I've got 2x times 1 is 2x. Negative 3 times x is negative 3x. And negative 3 times 1 is negative 3. So when I combine like terms, I have 2x squared minus x minus 3 when I multiply those together. So what I can say is 2x minus 3 and x plus 1 are binomial factors of 2x squared minus x minus 3, which is what we call a trinomial because it has three terms. Tri. So let's break this down a little bit. Where did we get our first term, 2x squared? Where did that come from? Well, we multiplied 2x times x. So this right here, 2x times x. What about that negative x, which I like to call our middle term? Well, we multiplied 2x times 1, and then negative 3 times x, then combined like terms, which we just kind of added them together. And then what about that negative 3? Where did that negative 3 come from? I like to call that our last term. Well, that came from this negative 3 times 1. So basically, we're multiplying very specific parts of these two binomials, the first part in each binomial to get the first term, and the last part in each binomial to get the last term. Then we have our middle and outside, I like to call it, outside and inside terms. We added them together to get that negative x. So factoring is the opposite of multiplying, aka dividing. And we're going to do this process backwards. We're going to give you a trinomial, and we're going to go backwards to get the binomial factors, hence the name factoring. So when I have x squared plus 4x plus 3, I'm looking for its two binomial factors. And if we look back at the process we just went through, the first term came from the first spot in each binomial. Well, think about, this is a 1x squared. So what two numbers multiply to 1? Well, it has to be 1x and 1x. It's the only way to get to 1. Then this 3, our last term, goes in the last space of each binomial. 3 is 1 times 3 or 3 times 1. Those are our only options. But luckily, it doesn't matter since I have a 1 here. These are the nice problems when there's a 1. So if I go 3 and 1, I just need to check. You have to figure out if they are positive or negative. That's your decision. That's your next goal. Once you split up the first and last term, you have to figure out the symbol. So we call this guess and check because we literally are guessing and checking until we get the right combination. So my inside here is 3 times x, 3x. My outside is 1 times x is x. So I'm thinking to myself, can I combine like terms to get to this positive 4x squared? Now, something I want you to notice is you're figuring out if they're positive or negative. But this 3 is positive, so that means my 1 and my 3 are either both positive or both negative, because a positive times a positive is a positive, and a negative times a negative is a positive. So if they're going to add up these middle terms to 4x, it needs to be a positive 3x plus a 1x. So we're going to say that it's going to be x plus 3 times x plus 1. It's the only way to get it to work out. So really we were looking for something that multiplied to 3 and added to 4. And we got 3 and 1. So number 2, I'm starting with my 2 binomials. And I need to split my first term into the first space in each binomial. So what 2 numbers multiply to 2? Think about it for a second. Well, it has to be 2x and 1x. It's the only option. 2 times 1 is the only thing that's going to add to 2 here. 2 times 1. Then I have another 3. And I need to put it in my last space. And remember, this is either 1 times 3 or 3 times 1. And this 3 is positive. So they're either both positive or both negative. Just because I have to multiply them together to get positive 3. So let's check here. Let's guess, and then check. So let's try 1 and 3. So that gives me a 1x and a 6x, multiplying inside and outside. And I'm wondering if I can combine these after you decide if they're positive, negative, to add to positive 5. Well, I could do positive 6 minus 1, but I have one problem here. Now I have one positive, one negative, but we already talked about how they both need to be positive or they both need to be negative. So this doesn't work. So we got to try something else. So you should always use pencil and eraser, because I'm about to erase this and try again. I just tried 1 and 3, and that didn't work. So my only other option is 3 and 1. So let's try 3x and 2x. And can you combine those to get that positive 5? You absolutely can if they are both positive. So the answer here is 2x plus 3 times x minus 1. So there I went through both combinations. Remember, you have to guess and then check before you move on. So this topic can be confusing at first, but only at first, because the more you practice, the better you're going to get. So if you want to rewatch those examples, I highly recommend watching this video as many times as you need before moving on. So we're going to keep factoring, but before we move on, I want to talk about what the greatest common factor is. The greatest common factor is the biggest number you can divide from all terms. I mean all of them. So if I look at 3x squared and 9x, we need to find the greatest common factor. Well, what can I divide both of those terms by? The first thing I see is a 3. And then they both share an x, so I can actually divide out a 3x. So 3 divided by 3 is 1, so I'm not going to write that down. X squared divided by x is just x. Because remember, if you were to multiply back, you'd have to get back to that 3x squared. I'm dividing. So plus, keep the plus, 9 divided by 3 is 3, and x divided by x is 1. It cancels out. So here I have 3x times x plus 3. You always need to look at what's inside your parentheses when you're done to see if you can keep factoring. But that's just a binomial, so I know I'm done. Let's look at number 4. Always look for the GCF first. So here, the only thing I can divide by all 3 terms is 2. So I'm left with x squared plus 2x minus 3. And now, inside my parentheses, I have a trinomial. I'll highlight that. This trinomial right here. And since it's a trinomial, I know that I can attempt to factor it. So you always have to be paying attention. So the 2 is going to stay chilling out front. And I'm going to make my 2 sets of parentheses. And I'm factoring now what's inside the parentheses. So this is a 1x squared. So then I'm looking for 2 numbers that multiply to 3, negative 3, and add to 2. Right? Because my 3's have to split and my x's have to split. So I have a 3 and a 1. That's 3 times 1 is the only thing that multiplies to 3. And it has to be a positive 3 minus 1, right? 3x minus 1x is going to give me positive 2. So my answer is 2 times x plus 3 times x minus 1. So sometimes you have a GCF and it's going to hang out in front so we can factor the rest. But it doesn't always have a GCF, so always check. So let's keep going. Factoring's so fun, isn't it? So this is a trinomial, no GCF. I can't divide any of the numbers or variables by each of the terms, so I go right to my two binomials. So I'm splitting my first term. I've got 3x and 1x, because 3 times 1 is 3. And then I have a 5. It's either 1 times 5 or 5 times 1, and it's negative. So 1 is positive and 1 is negative. I know that for sure. So if I choose 1 and 5, I've got 1x and 15x. Can those add to 2? No, you're right. That is not a good option. So let's choose my other option of 5 and 1. Then I have a 5x and a 3x. And I'm wondering, can I combine those to be a 2? Absolutely. If I have a positive 5 and a negative 3, yep, I've got my answer here. Alrighty, trinomial, no GCF. I've got a 1x squared. Remember, those are the happy ones. Make them easy for us. Going to be x and x, because 1 times 1 is 1. 1 times 1 is 1. And then I've got 6. It's either going to be 1 times 6 or 2 times 3. And they have to add to negative 1. So as you get better at factoring, you're going to make better choices. I'm going to start with 2 and 3, because I already know that I can somehow make those be negative 1. And you can if it is positive 2x and negative 3x. All right. So number 7 has a GCF. I want you to try number 7. I'm going to give you a hint, though. I'm going to tell you that the GCF is 3. And when I divide everything by 3, I've got x squared plus 2x minus 3. I want you to keep factoring. And I'm going to start number 8 for you, too. So our GCF here, what do you think? Well, they all can be divided by 2. And this one's awesome because they can all be divided by an x as well. So if I take away 2x for everything, I'm left with x squared plus 2x plus 1. Remember, 2x divided by 2x, something divided by itself is 1. So what I want you to do is to finish factoring 7 and 8. And you may need to rewatch this video a couple times, watch a few problems, make sure you're doing your very best to know what's going on before you come to class. Look forward to more practice.